Until March 23, 2005, BP's Texas City, Texas refinery was one of America's most substantial energy producers. At full capacity, it processed 11 million gallons of gasoline, or roughly 3% of the country's daily consumption. But at 1:19 in the afternoon on that fateful day, a vapor cloud of combustible gas was spreading through the refinery. 60 seconds later, it found an ignition source. America's third largest refinery suffered a major explosion. The power from the blast wave set off a series of secondary explosions, decimating a large portion of the facility.
The wave of the explosion was really something to behold. A lot of windows broke within a radius of at least half a mile away. The magnitude of this one was really unprecedented.
"15 people located in temporary work trailers were killed instantly. Over 170 others were counted as injured. It became one of the worst petrochemical disasters in the United States in 15 years.
The most tragic thing about this is this accident could have been prevented in any one of a dozen different places, but it wasn't, and it should have been.
The epicenter of the explosion was the refinery's isomerization unit, or ISOM. A key component of the ISOM unit is a distillation tower, called a raffinate splitter. The 164-foot distillation column separates out light hydrocarbons that are used to raise the octane level in gasoline. The process starts with feeding hydrocarbons into the tower, where they're then heated. The light vapors rise to the top, where they cool and condense, while the heavy liquid remains at the bottom. Although it stands 164 feet tall, operating guidelines limit the maximum fluid level inside at 8 feet. This allows for proper distillation and prevents overpressurizing the tower. Yet, according to investigators from the United States Chemical Safety Board, workers regularly operated the tower outside safe limits during startup.
Operators stated that it was typical practice to fill the tower to a higher level to allow for sufficient liquid and avoid a drop in the tower level when the bottom liquid was being heated up. The operators were concerned that a low liquid level in the tower could kill the startup process.
If the tower overpressurized, emergency relief valves would divert vapor and liquid to a disposal system called a blowdown drum.
The drum had a vent stack that was open to the atmosphere. This resulted in a history of releases from the stack that formed vapor clouds at or near ground level.
If you have a lot of that vapor vented to the atmosphere and there is a spark, that thing is really ripe for explosion.
A safer alternative is a flare system, which burns off vapor and collects the flammable liquid. Yet, despite ample profits, BP never fitted their blowdown drum with a flare.
If safety and mechanical integrity, reliability, and environmental protection are not being focused on, then other things take its place. And management becomes risk blind to the growing risk that there may be an imminent hazard or an imminent disaster about ready to happen.
The events that led to the disaster commenced during the early morning hours on March 23rd, as workers began feeding liquid hydrocarbons into the ISOM's raffinate tower.
The tower level began to build in the bottom 10 feet of the 164-foot tall raffinate splitter tower. At approximately 3 in the morning, the high-level alarm went off in the tower, indicating that the liquid level had reached 72% of the bottom 10 feet.
As they had on previous occasions, workers acknowledged the alarm, but continued to feed the tower. When the liquid level reached 9 feet, a secondary alarm failed, and the level continued to rise. Since the tower's level transmitter only indicated height up to 10 feet, workers soon had no way to ascertain the rising level inside. When workers completed the initial startup process that evening, 13 feet of flammable liquid hydrocarbons filled the bottom of the tower. At 10 a.m., operators resumed the startup of the ISOM unit, sending additional liquid feed into the raffinate tower. The level inside was rapidly rising.
The level transmitter was malfunctioning, giving an inaccurate level, indicating that the level was dropping while the level was actually rising rapidly towards the top of the 164-foot tall tower.
At 12:40 p.m., the level inside the tower topped 130 feet. Pressure inside the column was growing, triggering a pressure alarm in the refinery's control room. Operators quickly jumped into action. They opened a vent valve on the raffinate tower to relieve pressure and began sending the heated liquid to a storage tank.
The removal of liquid from the bottom of the tower should have helped conditions. However, the liquid leaving the bottom of the tower was hot. It was 304 degrees. There was a heat exchanger that exchanged the heat between the feed that was leaving the tower with the feed that was entering the tower. This caused the temperature of the liquid entering to jump 140 degrees.
Liquid began to boil and expand inside, eventually reaching the 164-foot ceiling and spilling into an overhead pipe. Within minutes, the pipe filled to capacity, forcing open an emergency relief valve that diverted the highly flammable liquid to the refinery's blowdown drum.
The blowdown drum began to fill with liquid, and in a matter of minutes, the blowdown drum had filled up and liquid erupted out the top of the blowdown stack in a geyser-like fashion.
A vapor cloud quickly engulfed the area. Investigators believe that a running diesel truck located 25 feet from the blowdown drum ignited the gas. The refinery's importance to America's energy needs led the United States Chemical Safety Board to investigate the disaster. They uncovered a history of shocking safety lapses at the Texas City refinery.
They had 4 episodes where they'd actually released gasoline out of the top of the same equipment that eventually caused the explosion.
In 2002, BP considered replacing their outdated blowdown drum with a flare system. Unfortunately, it took a tragedy for the oil giant to finally take action.
BP has announced and taken steps to eliminate all the blowdown drums that handle flammable hydrocarbons from the facility.
OSHA fined BP a record $21 million for egregious willful violations at its Texas City refinery. Not only was the explosion in Texas City tragic, it may be symptomatic of a much larger issue.
The whole refining industry in the United States is a disaster waiting to happen. It's absolutely obsolete, outdated, old, bad from every conceivable way that proper engineering would like it to be. We haven't had a new refinery in the United States for 30 years now. Unfortunately, the Texas City disaster, bad as it was, it's probably not going to be the last one because all the conditions are there for it to happen again.
Since the tragedy, BP has announced that it will invest $1 billion to modify and improve its Texas City facility. Just off Interstate 44 near Eureka, Missouri, lies a brand new state park. It features a playground, bike trails, and a Route 66 museum. What you won't find is any evidence of what was once the town of Times Beach. No, the town didn't move. It simply doesn't exist anymore.
Times Beach was founded in 1925 by the St. Louis Star-Times newspaper. If you bought a lot in Times Beach, you got 6-month subscription to the newspaper. It was named Times after the newspaper and beach because of the Merrimack River, which ran alongside the community.
In its first incarnation, Times Beach was modeled as a resort town, a summer retreat for the well-to-do. But by the 1970s, the city had transformed into a lower middle-class suburb of roughly 2,000. The town struggled financially and could never raise enough money to pave its 23 miles of dirt streets and roads. Plagued by dust in the summer months, residents procured the services of a waste oil company to take care of the problem.
The neighbors would get together and they would have the streets sprayed just in their area to suppress the dust. And then in 1972, the city contracted with Russell Bliss to spray at will. And he did that in 72 and 73.
A lot of little suburbs would hire me to oil their roads. I do a lot of little communities. Times Beach was pretty big, and it would take a couple loads to do the whole town. But with all the wear and tear, I'd have to do it maybe once every couple weeks or once a month.
But Bliss didn't use just oil for dust control. During the years he sprayed the roads of Times Beach, he used a mixture of industrial waste that he obtained from various suppliers, including the Napaco Chemical Company in Verona, Missouri. Napaco shared the facility in Verona with another company named Hoffman Taft. Hoffman Taft produced the chemical 2,4,5-T, while Napaco produced hexachlorophene.
2,4,5-T is the short name for a pesticide which was combined with another pesticide, 2,4-D, and together formed the compound which is commonly known as Agent Orange. Hexachlorophene is an antibacterial agent. It was used until it was banned in soaps, toothpastes, and other medical supplies. Both of these chemical manufacturing processes created a waste stream which was laden with dioxin.
Dioxin is a known carcinogen. But in 1971, little was known about its harmful effects, and there were no federal laws in place regarding how to dispose of it, or any industrial waste.
They could have told me it's cream cheese. I wouldn't know the difference between that and dioxin. I wouldn't know what dioxin really was. And at that time, I don't think if I would have put a sign on the side of my truck, I'm hauling dioxin from Verona to St. Louis, I don't think anybody would have known what it was.
He hauled tanker trucks of this material where it was mixed in large holding tanks. He then would draw down off of this and use the resulting mixture to spray on unpaved roads, parking lots, and in some cases horse arenas in order to control dust.
1971 brought the first sign that Bliss's brew was toxic when a number of horses died at an arena he sprayed.
The owners of the arena contacted the state health department to seek their help in trying to identify the toxic agent. The Missouri Department of Health then solicited assistance from the U.S. Centers for Disease Control.
In 1974, the CDC identified dioxin as the toxic agent responsible for the horse deaths. That drew in officials from the Environmental Protection Agency, which eventually traced the dioxin to the Napaco facility in Verona, Missouri, and to Russell Bliss.
We had a list of places where Russell Bliss was alleged to have sprayed dioxin-contaminated waste oil. EPA was able to identify a number of locations to sample, and in fact, we did identify Times Beach as one of the locations.
Residents of Times Beach were dismayed to learn they'd been living on dioxin-contaminated soil for over a decade.
I had no idea what dioxin was. I had no idea what it was used for, how it was manufactured. I only knew that a front-page newspaper article said dioxin, the most potent chemical known to man.
My name is Russell Martin Bliss.
The state made a big to-be out of it. They said it was the most deadly poisonous known to man. Well, I went before a hearing of a bunch of political people in Jefferson City, and I took my finger to it and tasted it, and never affected me.
Because I wasn't told what was in the oil. I wouldn't have known what it was if they had told me what it was. If you want the truth, you could tell me it was some kind of a new jelly, and I'd put it on toast and eat it. Because I didn't know what dioxin was. I swear to all of you, I had no idea this material was bad.
In November of 1982, the EPA took soil samples from Times Beach to ascertain the severity of the dioxin contamination. On December 23rd, just 2 days before Christmas, their worst fears were realized.
EPA was receiving the initial results from the lab sampling that indicated dioxin concentrations as high as 100 parts per billion existed on the roadways.
Dioxin is considered hazardous to humans at only 1 part per billion. Times Beach was abandoned. With their city deemed unlivable, residents lobbied for a buyout.
They knew that there was no technology available to clean up the community, and they knew they couldn't move back because it wasn't safe.
In 1983, the estranged residents of Times Beach got their wish. The federal government's Superfund program, which provides funds for hazardous waste sites, paid residents for their property. Soon after, the state of Missouri disincorporated the city. For over a decade, the hazardous waste site was gated off and patrolled 24 hours a day. The once thriving community was transformed into a ghost town. Finally, in 1997, after the completion of numerous investigations and lawsuits, the EPA embarked on a massive cleanup effort. All standing structures were bulldozed and placed inside a landfill the size of 4 football fields. The EPA then brought in a massive incinerator to purge the dioxin from the Times Beach soil.
That material was excavated and transported by covered trucks, and then it would go through a double airlock into a material handling facility where the trucks were dumped and managed under very controlled conditions. The material would then be augered in a closed system up into the entry to the incinerator. The gases would be evaporated at a temperature of 1,700 degrees, and then the gases themselves, which contained the dioxin molecules, would flow into a secondary combustion chamber, which would actually destroy the dioxin molecules at a temperature of more than 2,100 degrees.
Over $200 million later, the cleanup project came to an end. In 1999, Times Beach was reborn as a state park. Today, wildlife flourishes here, showing no ill effects from the deadly dioxin that once permeated the soil. But some of the town's former residents feel they aren't as fortunate.
I had 8 brothers and 1 sister, and what we had as children growing up was bruises, scratches, a few stitches, maybe a broken arm. Nothing like my family. Every member of my family was ill with something different. So you have to believe that it's because of the exposure to the chemicals.
I felt that there was nothing wrong with the oil. I didn't even think about anything being wrong with the oil.
Russell Bliss was never found guilty of any criminal behavior resulting from the dioxin contamination. Yet, many still see him as the man that killed the city of Times Beach.
When you say dioxin or Times Beach, you don't think about Napaco. You don't think about all the other companies that were involved in it. You think of one thing, Russell Bliss. But to this day, I will say this. I didn't generate it. I didn't make it. I hauled it from there and put it over there. I was a transporter, no more, no less.
Times Beach may no longer exist, but the physical and emotional scars of those that lived through its demise endure. September 11th, 2001. Al-Qaeda operatives hijack and crash 4 U.S. commercial planes, bringing down the World Trade Center towers and damaging the Pentagon. Just 2 months later, it appears that the unthinkable happens again. November 12th, 2001. American Airlines Flight 587 mysteriously falls from the sky shortly after leaving JFK Airport. It crashes into a residential neighborhood in Queens, New York. All 260 passengers and 5 people on the ground are killed. The FBI and investigators from the National Transportation Safety Board quickly mobilized to determine the cause.
We assembled a team of probably 15 people to immediately fly up to New York and begin the investigation. It was impossible, really impossible, not to at least at some level, assume that it might not have been an accident and it might have been a terrorist act.
The FBI found no obvious evidence of terrorism at the crash site. But investigators for the NTSB uncovered a vital clue that suggested a mechanical failure.
The vertical stabilizer was located in the water in Jamaica Bay, about a mile from the accident site. We knew that some part of the aircraft structure had failed, and our big job was to figure out why.
To lose a vertical fin is a pretty serious situation. It makes the airplane very difficult to control, if not impossible. In this case, apparently impossible.
An aircraft's vertical stabilizer, which includes the rudder, provides lateral stability during flight. Take it away, and the airplane will wallow from side to side, lose altitude, and crash. Flight 587 was on an Airbus A300-600 aircraft. The vertical stabilizer had a unique quality. It was manufactured from composite material, layers of carbon fiber that provide a lightweight alternative to aluminum.
And we saw the 6 lugs made up of composite material broken. The rest of the fin, the composite fin was in the bay. The lugs that were supposed to hold it on were there, but they were cleanly broken off.
The investigation team soon made an equally important discovery. They recovered Flight 587's flight data recorder and its cockpit voice recorder. With these key pieces of evidence, NTSB investigators embarked on the lengthy process of determining what caused the vertical stabilizer of Flight 587 to fracture. They started by scrutinizing the structural integrity of its composite material.
We tested it down to the micro level, so to speak, by pulling bits of it apart, make sure it was strong enough. We concluded that the design of the structure was satisfactory, and in fact, the strength of the material was stronger than it was designed to be.
Investigators then turned to analyzing Flight 587's voice recorder, a key piece of evidence, allowing them to eavesdrop on the pilot's final words.
When we listened to the voice recorder, we heard the captain mention wake turbulence. Then we went back to the recorded radar data, factored in the winds, and proved that indeed he did run through this wake turbulence.
Wake turbulence is rough air that forms from the wingtips of airplanes. Studies show that wake turbulence resembles a horizontal tornado. When encountered by another aircraft, the vortex causes the wings of that aircraft to dip down or bank.
It was immediately evident that wake turbulence in itself couldn't have caused this accident. For one thing, there was 5 miles of separation. For another thing, the airplanes were already well established in the climb, and that means that they were going at a pretty good speed. The strength of turbulence diminishes as speed increases, and so it just didn't make any sense.
Having ruled out wake turbulence and the vertical stabilizer's composite material, the investigation shifted again. NTSB officials conducted interviews to determine the competency of the co-pilot, who was commanding the aircraft when it crashed.
This one gentleman was a captain in a Boeing 727 when the accident first officer was his first officer. They ran into a bit of wake turbulence, and the first officer reacted strangely. In a sense, he activated the rudders back and forth several times, causing the aircraft to yaw quite heavily.
Fully deflecting the rudder back and forth as the co-pilot had done stood out as a red flag to investigators. An analysis of Flight 587's data recorder showed that the co-pilot had once again repeated this abnormal maneuver.
He jumped the gun on responding, and that as the airplane swung one way, he came in with opposite rudder, and that the airplane then swung back and overshot in the other direction because he had put in too much rudder control. And so he then went to the other rudder pedal and tried to correct this.
This led to a shocking revelation, dispelling any theory of a terrorist plot, that a pilot could inadvertently cause severe structural damage to an airplane at maneuvering speed.
Maneuvering speed is a speed below which, in the general understanding of pilots, any deflection of the controls can be made with any speed, any violence. The plane can be maneuvered in any way you choose without endangering the structure. However, it turns out that there was some fine print in the certification of airplanes, and one of the provisions in the fine print was essentially that you couldn't flap the rudder back and forth the way this pilot allegedly had done.
The A300-600 was somewhat susceptible to this type of anomaly. At the speed the aircraft was traveling, about 250 knots, it only took about 1 1/4 inches of rudder travel to move the rudder all the way to 9.3 degrees either way, and it only took about 32 pounds of rudder pedal force. And it takes 20 pounds just to get the rudder to move, so there's not a lot of margin there at all.
Good morning, Madam Chairman and members of the board. I'll be discussing...
The final report issued by the NTSB fell short of citing the Airbus A300-600 rudder sensitivity as a design flaw, but it did recommend that future Airbus planes incorporate a fail-safe mechanism that will prevent a pilot from critically damaging the aircraft. As of 2006, Airbus has yet to modify its A300-600. Nevertheless, since the crash of Flight 587, the Airbus rudder system has performed flawlessly.
This type of accident has never happened before. It hasn't happened since the accident, and we would hope it would never happen again.
On May 14th, 1973, a Saturn V rocket blasted off from Kennedy Space Center to thunderous applause. Attached to the rocket was precious cargo. The $2.5 billion Skylab, America's first space station. But seconds after takeoff, disaster struck. A gap of less than ½ centimeter between Skylab's thermal heat shield and the body of the space station allowed a pocket of air to form underneath. The resulting pressure snapped the 3 aluminum tension straps that held the shield of the spacecraft, causing it to rip away. Soon after Skylab reached its intended orbit, Mission Control realized the space station was critically damaged.
The temperatures inside the workshop began to go up, and it didn't take them too long to figure out that they had lost the heat shield during launch. And this heat shield ripped around to solar panel number 1. It took it off the vehicle too, but when it got to the second solar panel, it ripped around it, fortunately, and left it intact. But a piece of aluminum strap from the heat shield riveted itself into the solar panel cover and kept it from deploying more than about a foot.
If Skylab's second main solar panel were set free, the space station could generate enough electricity to perform its mission. But without a thermal heat shield, the temperatures inside Skylab would make it unlivable. If Skylab were lost, the future of the American space program would be in jeopardy. The crew of Skylab 2, who were to occupy the space station the following day, had their mission postponed indefinitely.
There were questions that had to have answers in order for us to go. One was, how can we get some kind of a sunshade over the sunny side of Skylab to cool the temperatures so that it's livable in the first place? The second one is, how do we get that solar panel freed up?
Devising a plan for how the astronauts could attach the replacement heat shield to the space station would be the biggest hurdle. Several NASA departments worked on designs that involved the astronauts replacing Skylab's heat shield while performing a spacewalk. But the tethered constraints necessary for a spacewalk would make it difficult to deploy and anchor a replacement thermal shield. NASA engineer Jack Kinsler used some inside information to develop a different strategy.
There was a trainer equivalent to it right in the buildings where I worked. So I thought, why don't I walk over to the building and look around? There was a camera that was designed on the outboard end of the Skylab, and I saw that camera port. And gosh, I knew it was near the damaged area. So my thoughts just clicked over, and I bet I can put something through that 8-inch port that can expand and get big enough to lay out a very repairable piece of material.
Kinsler ran with his idea. Within hours, engineers stitched together a 24-square-foot piece of mylar and placed it inside a 4-foot-long, 8-inch-wide aluminum box that would fit Skylab's scientific airlock. Kinsler then demonstrated his theory to NASA chiefs.
Now, there's at least a dozen people there, all the top people from NASA that could get close to it. And they were there watching all this. So the instant that thing splayed out on the floor, I had them all walk over to me and say, "You've got it. That's it."
With NASA's approval, Kinsler's group started building Skylab's replacement sunshade. After the fabric for the parasol was complete, Kinsler worked on designing a deployment mechanism that would allow his parasol to open up in a uniform fashion, much like an umbrella.
I had devised a 4-way spring. It had 4 coil springs all set in a little container. They were timed in such a way that as soon as they emerged, they would all spring simultaneously, and they open up all 4 sides.
Just 9 days after Skylab reached its planned orbit, Kinsler's sunshade was rushed to Cape Canaveral and placed inside a Saturn IVB rocket, designated Skylab 2. Its crew, Joe Kerwin, Paul Weitz, and Pete Conrad, would attempt to save the crippled space station.
We got her in daylight. Solar Wing 1 is in fact partially deployed in the region that you...
On May 25th, the astronauts of Skylab 2 docked with the space station and felt the impact of Skylab's lost heat shield firsthand.
The docking adapter and the airlock were not extremely hot because they hadn't lost their heat shield. The workshop where we are now had lost its heat shield, and it was about 130 degrees. It was very hot. It was like being in the engine room of an old Navy ship. Pete Conrad and Paul came back down with the container containing Jack Kinsler's parasol. What Pete and Paul did was to take the container, stick it into the sunny side airlock, and deploy the parasol through it.
Per Kinsler's design, Weitz and Conrad connected a series of 6 32-inch-long interlocking rods. They then pushed the assemblage through an opening in the back of the metal canister, attaching it to the parasol. The astronauts then opened the airlock and used the push rod to move the parasol out into space. Conrad then pressed a release knob that activated Kinsler's spring mechanism, forcing the sunshade open. The temperature inside Skylab eventually stabilized at 80 degrees. Days later, the astronauts performed a spacewalk and freed the jammed solar panel. With only one main solar panel and a makeshift heat shield, Skylab looked worse for wear, but the space station worked.
Well, Apollo 13 was the mission where the crew was saved by flight control. Skylab was the mission that was saved by the engineering community. It was a great 10 days watching everybody do their job.
Astronauts Joe Kerwin, Pete Conrad, and Paul Weitz lived on Skylab for a record 28 days. Over the next 12 months, 2 additional manned missions to the space station followed. In 1974, the hugely successful Skylab program came to an end. On June 24, 2005, fire erupted at the Praxair Gas Company in St. Louis, Missouri. The blaze quickly progressed into a raging inferno, sending pressurized acetylene gas cylinders rocketing through the air. The flying projectiles terrorized residents and destroyed property throughout a neighboring residential area.
Praxair repackaged industrial gases from large bulk containers into smaller containers that were used by the local industry in St. Louis. The facility was handling about 30,000 cylinders, of which a vast majority were outside in a yard on an asphalt paved area.
On the day of the disaster, St. Louis was in the midst of a sweltering heat wave. By mid-afternoon, temperatures neared the century mark, creating a volatile environment for pressurized propylene tanks.
The gas is maintained a liquid under pressure, but as you add temperature to it, the pressure increases.
Adding to the heat was Praxair's asphalt yard, which drove temperatures well above ambient inside the cylinders. The amplified pressure of hot, expanding gas caused a safety pressure valve on a cylinder filled with propylene to open.
The safety release device opened and allowed this highly flammable gas to vent. As the gas vented, the gas actually cools due to expansion, and little droplets of liquid form as the gas is venting, and these create a static charge which allowed a self-ignition to occur, igniting the cylinder.
The fire quickly spread to adjacent cylinders, which became superheated and leaked additional flammable gas. A chain reaction of explosions startled residents in the surrounding Lafayette district.
It just got bigger and louder to the point that we were like, something's wrong. And you could just see these flames that looked like a mushroom cloud. I mean, literally hundreds of feet tall with shrapnel coming out of them.
An emergency dispatch reached the St. Louis Fire Department, which quickly responded.
When we came up on the scene, I would describe it as a war zone. We're seeing these pieces of metal in the street. Initially, we don't know what they are, but then they start falling down in front of us, and we realize that these are these tanks.
Hundreds of tanks shot through the air, crashing through brick walls and setting cars on fire. The chaotic nature of the blaze forced firefighters to take a step back. To protect themselves, they stationed unmanned hoses on towers to douse the flames. They then shut down the highway, canceling that evening's baseball game at Busch Stadium, and began evacuating the neighborhood. Local resident Scott Edmondson nearly lost his life when a cylinder crashed through his bedroom.
And this was a bedroom. I ran back here looking for the cat. And there was a bed here. It knocked me about 3 feet down, 3-4 feet down. These were all the bricks that came down upon the bed and the room and tore through this whole roof here.
It took several hours for firefighters to extinguish the raging inferno. Luckily, no one was killed, and only a handful of residents were injured. In the days that followed, officials from the United States Chemical Safety Board began investigating the cause of the fire. They discovered that the valve on the leaking cylinder prematurely opened, a result of weak design standards associated with many gas cylinder valves.
The valve operates by a spring-loaded mechanism, and there's a small disc inside the valve which covers a gas port. And as the pressure builds up under that disc, it compresses the spring and it opens. And the spring rate establishes the setting of the valve. The particular valves that are used on these cylinders tend to have a lot of variability.
Praxair has subsequently replaced all the relief valves on their propylene cylinders. Approximately 1 year after the fire, Praxair announced plans to reopen its St. Louis facility. Residents in the Lafayette district were outraged, as some were still working to repair the damage caused by the flying cylinders.
Basically what it came down to is that it is incompatible to have a residential neighborhood and that type of industrial business right on top of each other. It came down to safety, pure and simple.
The concerned residents got their wish. Soon after their announcement, Praxair changed its mind. It relocated its St. Louis facility to Illinois, in a non-residential area.